The EuCAPT video profile series consists of interviews with members of community active in theoretical astroparticle physics and cosmology. In these interviews, we discuss what's exciting in research, life in academia, and developments within the research community. My name is David Marsh. I'm an assistant professor at Stockholm University. And to conduct this interview with me, I have
Nico Sarcevic, a PhD student at Newcastle University. Today, we are very happy to have Gianfranco Bertone with us. Gianfranco is a professor of theoretical astroparticle physics at GRAPPA Center at the University of Amsterdam. He leads a research team investigating topics at the interface between the particle physics and cosmology. He is also, since 2019, the founding director of the European Consortium for Astroparticle Physics, EuCAPT, which we will talk more about in due course. So welcome, Gianfranco. Let's start by getting to know you a little bit. So first of all, where are you from and how did you become interested in science?
Thank you. First of all, thank you, David and Nico, for this initiative, and thank you for having me. I was born in the south of Italy in a region called Calabria. And I remember we had like a young people's encyclopedia at home that I really liked to read. I think this was my first introduction to the world of science. I remember that when I was like 9 or 10 years old, I told my parents I wanted to be a scientist. I didn't know what that meant really. But then eventually, thanks to some friends who inspired me and thanks to some teachers who guided me, I managed to find my way.
Would you mind briefly describing your career trajectory to date? So that means which positions have you held, where and when?
Sure. That's going to be a pretty long list. I did my undergraduate studies in Rome, and they were specialized in theoretical physics. Actually, I did my master thesis in theoretical astrophysics and general relativity. Then I did another master in this time in astrophysics and cosmology in Paris, and there I met my future PhD supervisors, who were Günter Siegel and Joe Silk. And with them, I did my PhD with Joe Silk at the University of Oxford, and then with Günter Siegel at the Institute of Astrophysics. And then when I finished my PhD, I got an offer to a postdoc offer at Fermilab in the United States near Chicago. And so I went there, came back to Europe. I accepted a German fellowship at the University of Padua, but almost immediately actually I got an offer from for a permanent position at CNRS, the Institute of Astrophysics in Paris. So I went there. I thought I would be there for a long time. But then my wife, who's a neuroscientist, got an offer from Zurich for a postdoctoral position in Zurich. So I went there as a visiting professor for 2 years. And when this position ended, there was this very exciting opportunity in Amsterdam, where they were starting a new interdisciplinary group. It's called the GRAPPA. And this was a collaboration between the theoretical physicists, the high energy physicists, and the astronomers. And I thought this would be, the perfect place for me. So I came here to Amsterdam. I was the founding coordinator, spokesperson of this GRAPPA Institute until I stepped down to start EuCAPT.
Switching to research. So in your career so far, at what point were you the most excited and what were you excited about?
So at the personal level, really, there is this constant pleasure of discovery of small things, so to say, of figuring out something new that I would say is really the main driver for me as a scientist. This is what gives me the main motivation for me to be a scientist. Actually, connecting to what I was saying earlier, I clearly remember the fascination when I was reading in these books when I was a child about science, and this sense of almost of vertigo when you learn something new. Of course, you cannot find that vertigo by reading books all the time, because at some point you reach the edge of what is known in a certain field. And so for me, my main motivation has been to try and push, even just by a little bit, this frontier of knowledge. And that's the most exciting thing for me in my daily life. And speaking instead of bigger discoveries, I think that the discovery of the Higgs was one of the things that excited me most, because it really represented the end of a very long journey that started with this original idea that the Higgs and others had almost 60 years ago. And then, but this was, for me, more the end of a long journey, incredibly fascinating, incredibly exciting. Maybe the only thing that went beyond that was in my career, the discovery, the direct detection of gravitational waves. Because there again, it was the end of a long journey, but also the beginning of a new way of looking at the universe. And in my daily life, actually, my daily research work in my team here in Amsterdam, we actually try to see what we can learn from gravitational waves, from the observation of gravitational waves, on some of these biggest mysteries in the universe.
Continuing in the research direction, at the moment, what are the most exciting open questions in your research area?
There are many. And, if you think about the standard cosmological model, the standard theory that we have to describe the universe, we have this wonderful theory that explains almost all observations that we have in the universe. Is almost like this amazing architecture, this amazing cathedral of science that stands, though, on pillars like the theory of inflation, the concepts of dark matter and dark energy, which are all things we know very little about. And so we have this beautiful building, but we really need to consolidate the foundations of this building, because otherwise, there's no trust that this amazing architecture can stay up for a long time. And so, for me, really, as a scientist, in my team, we mainly focus on one of these three pillars, which is the problem of dark matter, and we try to figure out what that is, so to consolidate that particular pillar. But I'm also very excited about the new discoveries that will teach us something about dark energy and the theory of inflation.
So Gianfranco, now a more controversial question. So what do you like and what do you dislike about being a scientist?
Yeah, so I certainly like the freedom that we have to work on whatever we think is most interesting. I really like the best use I can of the flexibility that we have in our work, especially for people having a family. I think for everyone it's important, but especially for people having a family, having some flexibility allows you to spend time with the people in your life you care most. And maybe the most important thing is really the possibility to work on something you really like, you really are interested in. Most of the time it really, but for a good fraction of the time, it doesn't feel like working really, what I do. It feels like, doing something I'm curious about and I'm interested in. There are always also things, of course, that I dislike. And in particular, there's, so maybe the thing that I find most frustrating these days is that somehow, especially when you work in a big university or research institute, there is this idea that our time is almost infinitely compressible, so that maybe also because of the flexibility of our work, there's always something extra that you can do on top of what you already do, and the result is actually a very fragmented schedule. The time of a scientist today, the schedule is very fragmented, and we constantly jump from one activity to another, and this makes it sometimes difficult to reach that kind of focus that is really crucial, is fundamental if you want to do some deep thinking. You cannot solve the mysteries of the universe in the 17 minutes between a faculty meeting and and something else. So that's one of the things that I find frustrating, and I try to work very hard on creating time, making time for deep thinking, for the stuff that we want to achieve, really to align, maybe to put it in a different way, to align our daily schedule with our key goals, basically the most important goals, and not just the ones that are incredibly urgent because there's a deadline tonight, basically.
Very good point. Very good point. You mentioned already about how you're still very inspired and continuing to improve yourself. So what are the new skills that you're looking forward to gaining in the near future? So what are the skills that you want to develop?
Yeah, so there are two topics that I find fascinating, and I would like to know more about them. One is machine learning. We've been using machine learning for the analysis of LHC data, so for the search of particles beyond the standard model of particle physics. And I find that the whole field of machine learning truly fascinating. It's a field that is evolving very, very rapidly. This is quite different from what we typically do in physics. In the field of machine learning, an algorithm that was proposed like 4 or 5 years ago is almost prehistory. It's so obsolete that it's almost useless. So I'm trying to find a way of keeping in touch with that community. We set up collaborations, for instance, in my own group, where we can we try and do this in the most effective way. And then I'm also interested in learning more about gravitational waves. There again, this is a field already with a long history. So we started now in exploring the potential of gravitational waves as a portal to identify dark matter, to learn something new about dark matter. We're working now at, we're going in steps. So we started from solving the problems we care about in the context of Newtonian dynamics. We're going now to post-Newtonian dynamics. And eventually, when we go very close to merger, we're going to have to resort probably to numerical relativity. And that's something that, it's beyond my current expertise, and I would like to learn more about that.
What's the biggest obstacle, would you say, that is slowing down research in your area at the moment?
In the field of dark matter, we have many ideas about what dark matter could be. In fact, we have way too many ideas, and the problem is not that we don't know what dark matter could be, but there are too many good ideas, and we don't have enough data to discriminate among all these different ideas. In a way, the key problem is this really very elusive nature of dark matter that seems to behave as a particle that just has mass, is out there, interacts gravitationally with everything else in the universe, and doesn't interact much with ordinary matter. And so all the particles, all the candidates that have been proposed to explain dark matter that satisfy these criteria are basically equally good, and we don't have yet enough data to discriminate one from the other. So that's the key difficulty, and the challenge for us as theorists is really so there's a challenge for experimentalists, which is to build a piece of equipment that can detect this type of particles, or at least some of these particles, and then we make progress by either finding or ruling out some of these candidates. The challenge for us as theorists is really to try and come up with ideas to test these ideas with all the observables that we have. And in particular, we recently wrote a sort of a review article with a colleague in the US whose name is Tim Tate, where we suggested that we should do, as a community, we should do it at the same time, three different things. One is to diversify as much as possible the experimental effort, so to search wherever we can for these dark matter candidates. The second strategy we proposed was to really exploit astronomical and cosmological observations. So to go back to the drawing board in a sense and ask order zero questions, the key questions. Does dark matter interact with itself? Does dark matter interact with other stuff in the universe? Is it really this kind of cold collisionless fluid that we make use of to describe the properties of dark matter in the universe? And the third strategy is precisely the one that was mentioned earlier. There are new opportunities arising from this new window that we open on the universe, which is gravitational waves. And there's a lot we can learn about dark matter from gravitational waves for a variety of different particles, whether dark matter is made of ultralight bosons or cold collisionless particles. There is a way where these new observations can help in identifying those particles.
What do you hope to see accomplished scientifically in the next 50 years in this field?
Yeah, clearly my dream is that we will manage to solve the dark matter problem. That's something that, I felt was a goal that we could reach very soon, 20 years ago when I started working in this field. Instead of getting closer to the goal, I feel we step back a bit, and we are more distant really from finding the dark matter in the universe, identifying dark matter. But there are many ideas around, many good ideas around, and with some luck, I hope that maybe not 50 years, because I'm not sure I would be around in 50 years, but certainly within my lifetime, I would be it would be fantastic if we manage to identify dark matter.
Indeed. So going back to EuCAPT, you are the founding director of EuCAPT. So what was your motivation for being involved in the formation of this consortium?
Yeah, so this is actually a relatively old idea. So this idea of putting together research institutions in Europe and create a community of research centers active in theoretical astroparticle physics and cosmology is something that has been around for at least, I think, 8 or 10 years. And there have been attempts in the past to make that happen. The idea was quite obvious. If you want, we have something called the APEC, which is the European Consortium for Astroparticle Physics. This is basically a consortium where all funding agencies participate, and they get together to build the big infrastructure, experimental infrastructure in Europe for astroparticle physics, which is obviously something that no single country could afford to do. But if you look at how the discussion in the APEC documents is structured, there's, for example, neutrino physics, there's dark matter, the CMB, and there's theory, right? As if this was a sort of an independent topic in a long list that comes after this long list of experimental facilities. Whereas we as theorists think in a very different way. For us, the experimental infrastructure is something that is there and that enables us to address some of the fundamental questions that we have. And most of these questions actually require data from many different of these infrastructures, especially today where we're going in the direction of the so-called multi-messenger astronomy or multi-messenger astrophysics. We make use of light, a variety of wavelengths, but also neutrinos, but also gravitational waves to figure out the big problems, the nature of dark matter, the nature of dark energy, and so on. So it made a lot of sense to have a sort of a parallel consortium that brings together theorists around topics that are of interest for the whole. community. And in fact, we do have this very strong community of theorists in Europe, but very often we don't act as a community. And there were cases, well, I was a witness of one of these cases a few years ago, where several groups of institutions in Europe were basically competing with each other to attract European funds to create European networks, right? And then you have groups of institutions that compete basically for the same thing, for doing literally the same thing. And that sends completely the wrong message, of course, when you try to apply for this type of funding, because you basically demonstrate that you're not acting as a community. You know, the community is too fragmented, and there's no reason why you should fund one and not the other. And similarly, we had cases where, you know, schools on very similar topics were organized almost around the same dates by different groups of institutions. So there's a work of consolidation that we already started that I think is important. But I think the importance of EuCAPT also goes beyond this simple kind of logistics and coordination, because there's so much more we can do as a community. I'll give you one example. You know, one of the workshops that we organized, we asked a question. We asked participants to tell us about projects they would like to work on, but they don't have the full expertise to conduct that type of research. And if they had a collaborator with the right expertise, they would be very happy to work on that. And that's where EuCAPT can really serve as a catalyst for these collaborations, bringing people together, and just making sure that the community is more than the sum of the individuals that make it.
EuCAPT has recently held its second annual symposium. So how's EuCAPT doing at the moment, and what are the exciting new developments?
The second symposium was very successful, I would say. I found and I can say this because you know, the organizers, most of the organizing work was done by the local organizing committee at CERN. I think they did really a fantastic job. EuCAPT, as I think demonstrated, is a very active, very lively community. Over the past year, we've had a number of interesting results that came out of EuCAPT. So we put together a white paper, for example, that basically is a reflection of the community on the next decade in our field. What is the status of our field? What are our hopes? And what is the best way, basically, to achieve our goals? This has brought together, you know, more than 100. I think we are around 120 or 130 authors. But the paper was also endorsed by 400 members of the community. So it's really an expression of the community, I would say. And this is being used by a lot of young people in our field to get a sense of what is going on in our community and what's exciting, really, what they should be looking forward to in the next decade. We're setting up a scientific exchange program to allow people, especially young people, to travel to other institutions for scientific collaborations, or to attend schools, or to participate in conferences. We also have set up a program of kind of longer-term visits to CERN, so we can, a typical case we have in mind is groups of individuals who met maybe at a conference or at a workshop, had an idea, they started working on together, but then need some, you know, time together at the same physically at the same place to turn that initial idea into a concrete project, into a concrete paper, to finalize the writing of a paper, you know, these kind of things. And that's something, again, that we start in now. And then we have also a program of workshops. We're working a lot on how to help young people getting the training they need. And actually, in the last EuCAPT symposium, an interest was expressed in forms of training that go beyond technical skills, you know, technical scientific skills, but also involve what are sometimes referred to as soft skills. So some sort of coaching for young people to understand what's important to know and to do to have a successful career in academia and beyond.
So Gianfranco, switching from physics and research and EuCAPT to something completely different, how do you like to relax after a period of hard work? What are your interests outside physics?
Well, my main interest these days is my two young children. So they're my hobby and my main source of relaxation when I'm not at work. In general, I'm a very active and curious person. I love sports, outdoor activities, but wherever I went, I tried to, do something that could have been, sometimes there were, art classes and painting and sculpture. I love photography. I love cooking. I volunteered in a nature museum when I was in the US. I try to engage as much as possible with the community around me wherever I am, and I would say that in general, I'm excited and intrigued and interested in everything that brings together art, beauty in some form, and technical skills at the same time. So that's what maybe in general what broadly defines my interest outside of science.
Okay, and the last part. So Gianfranco, what would be your advice to your younger self, and what kind of advice would you give your young colleagues that are only starting in the field?
I'll tell you what I usually tell my students and the young members in my group, which is to work hard, stay focused, believe in yourself, and choose as much as you can, as much as possible, a topic you're truly interested in, and try to choose supportive supervisors. Don't necessarily go for the flashy institutions and fashionable topics. Find something you really truly love and people who can support you in your career. And in general, I think it's also important for young people to understand that what's really important is to focus on themselves and to give their best. Getting a job at a top institution should not be the goal of your life, really, because it's it doesn't only depend on you whether you can reach that goal or not. You should really focus on things which are under your control, and what's under your control is work hard and give your best. And then if the opportunities are such that life gives you, as it gave people like me who've been very lucky to get access to a permanent position in academia, but there are many very bright people who were not as lucky as and I'm perfectly aware of that we're not as lucky as I was. So if your goal is outside your control, the risk is that then you perceive yourself as a failure if you don't get there. But there's no reason for you to feel that way, and especially if you align your work, your discipline to give the best you can, then you cannot really fail. You will achieve something in your life. You will know that you've given your best to achieve that result. And if the result is that you get a good career outside academia, so be it. There are many successful people outside academia who are living a very happy life. So that's what I would tell them.
That's very nice.
Yeah. So now we've reached the end of this interview, and we would like to sincerely thank you, Gianfranco, very much for this very interesting interview with fascinating responses, both about research and about life in academia and about EuCAPT.
Thank you, guys. Thank you for having me.
Yeah. And with that, we close this video profile. For more profiles that will be published in the future, please check the blog section of the EuCAPT webpage at eucapt.org. And with that, we say thank you very much again and goodbye.